Okay, today we're going to look at something called the Henderson-Hasselbalch equation, which takes a few steps out of a process like this. Let's take a look at a question from the homework yesterday. And what we're interested in, let me zoom in a bit on this, is these answers. Did you notice that when we had problem set A, I can't remember what number this is. I think this is the last one. The second to last one. That if we have 0.1 molar acetic acid and 0.25 molar sodium acetate, and we're not worried about the sodium, it's the ratio of acid to conjugate base. And when we had a ratio of 0.25 to 1, we got a pH of 5.14. Did you notice? If we take 0.25 and divide it by 0.1, we get 2.5. Did you notice that we got the same ratio here? And now the ratio of conjugate base to acid is 2 to 0.08. And did you notice that 0.2 divided by 0.08 is also 2.5? So what we're interested in is not so much how much acid and how much base, it's the ratio. So if we know the ratio and something called pKa, we can find the pH. So let's take a look at a problem that we saw yesterday. If you remember from yesterday, when we cranked this out, we got a pH equals 4.74. Is there a faster way to do this? Is there a way to calculate the pH just by using the ratio of acid to conjugate base? And the answer is yes. Welcome to what we're going to call the Henderson-Hasselbalch. We pronounce it Bach, but it's spelled Balch equation, and it looks like this. And I'm going to get a nice clean copy so my handwriting doesn't screw it up. This says that the pH of a buffer with a ratio of base to acid is equal to the pKa of the acid plus the log of the ratio of conjugate base to acid. There's another version. So these are the two versions that we use, and they both work fine. Notice that these two are exactly the same. But you can get the same answer if you put acid over base and subtract the log. So be careful. I would get used to one of these and use it all the time. They will give you the same answer. Whichever one you use, just don't get them mixed up. Don't say plus log of acid over base or minus log of base over acid. So it doesn't really matter which one you use. I tend to use this one, but it doesn't really matter. So let's try this problem that we saw yesterday, where we have a, hang on just a second. Sorry, we had a brief interruption here. So let's take this problem that we saw just the other day where we had 1 molar acetic acid, HC2H3O2, and 1 molar sodium acetate, which of course we know is going to dissociate into sodium plus the acetate, and of course that's going to be our conjugate base. And this thing called pKa, this is simply taking the negative log of the Ka. So pKa is going to equal negative log of the Ka, just like we have pH of H+. So let's try one of these. We've got We've got 1 molar acetic acid, 1 molar acetate, and the Ka for acetic acid is 1.8 times 10 to the negative 5th. So let's take our calculator and let's find the pKa. So let me bust out my fancy one. And what we'll say is negative log of our Ka 1.8 times 10 to the negative fifth. We get a pKa of 4.74. I wonder if that's a hint of what's going to come. So our pKa is negative log of 1.8 times 10 to the negative fifth. And so let's plug this pKa into the equation with our concentration of acid and base. pH is going to be equal to negative log, is going to be equal to pKa. We're going to use this version that's got the concentration of base over acid. And so we'll say pKa 4.74 plus log of concentration of our base, that's this guy, 1 molar, over our concentration of our acid, which is this guy, 1 molar. Let's plug that into our calculator and see what we get. And I'm going to do it all in one big shot. So we're going to say 4.74, that's the pKa, and we're going to say plus the log, and we have 1 over 1. We get, apparently this calculator can't do that. It shut off when I tried to get it to do it. Let's try it with the one in my hand. Then we'll say 4.74 plus log of 1 divided by 1. Isn't that interesting? 4.74. Isn't that the answer to the same problem we got last night when we did this? And I seem to recall that it was. Let's go to my notes. And it says that when we did this exact problem, we got a pH of 4.74. So it seems like the Henderson-Hasselbalch equation cuts a few steps out of the whole process. So let's try it. And remember, you want to be using the version that you are most comfortable with. And I like this one that's got pH is equal to pKa plus log of base over acid. If you use plus log, just remember the base goes over the acid. And of course, you're welcome to reference this set of notes anytime. Okay, so take that for a spin. I'll see you guys on the next one.